right, class, now we're going to talk about section 10.3, which is all about logarithmic functions. So remember that exponential functions have inverses that are logarithms. Okay, remember something's an inverse if when we reflect it across the y equals x axis, they're mirror images of each other. So we know that for all real numbers y and all positive numbers a and x, where a doesn't equal to 1, that log base a of x is x equals a to the yth power. So what we're really trying to find is an exponent. So if I wanted to know what y value would be if I have log base 2 of 8, that's saying what power do I raise 2 to in order to get 8, right? So I've got my 2 to the y equals x, which is 8, so y equals 3. Remember, they're the inverses of exponential functions. I want to remind us that. Also that we can write, instead of y equals log base a of x, we can also write f of x because it is a function, right? It passes the vertical line test. And it's a one-to-one function because it has an inverse, so it also passes the horizontal line test. Okay, so characteristics of log base a. It has the point 1 over a when it's negative 1. X is 1 when y is 0, and a when y is 1. So let's take a look at this. So if I had y was, let me write this someplace else and in a different color. If I had y equals log base 3 of x, okay, if I let x equal 1 over a, that's asking us what power do I raise 3 to, sorry, that's a y, in order to get 1/3. So then y would be negative 1. So we have this point here. If I have y equals log base 3 of 1, it's saying what power do I raise 3 to in order to get 1? Well, that's going to be y equals 0, because any number that's not 0 raised to the 0 power is 1. So we have this point here. Next, if I have y equals log base 3 of 3, well, log base anything to the same number is going to give us 1, because it's saying what power do I raise 3 to in order to get 3? Well, that means y is going to be 1. So why don't we go ahead and graph a couple? So I need to pick some x values that are part of, that are 2 to some power. So I'm going to take x is 1/2, x is 1, 2, 4, and 8. That's a lot of examples, but I want us to get practice. So if I have log base 2 of 1/2, that's telling us, what do I raise 2 to in order to get 1/2? And that means x equals, that means our y would equal y equals negative 1. If I have log base 2 of 1, that's saying what power do I raise 2 to get 1? Well, I gave it away. It's y equals 0. If I have log base 2 of 2, that log base 2 of 2 is what power do I raise 2 to in order to get 2? Well, that's going to give us 1. For 4, log base 2 of 4 is 2, and log base 2 of 8 is 3. So now we have lots of ordered pairs to graph. So let's go ahead and graph this. I have, When x is 1/2, y is -1. When x is 1, y is 0. When x is 2, y is 1. When x is 4, y is 2. And when x is 8, that's off my graph, that gives me y equals 3. Now notice I'm never going to have a negative y value because I'm never going to have a x value less than 0. So we've got an asymptote. We've got a vertical asymptote here. So I have a vertical asymptote at x equals 0. Next, let's say I have f of x equals log base 1/2 to the x. So I'm going to pick some x values that I can get. So I'm going to pick x's, what should I pick? How about 1/8, 1/4, 1/2, 1, 2, and 4. I know that's a lot of problems, but I want to make sure that we have a full understanding of this concept. So if I have log base 1/2 of 1/8, that's saying what power do I raise 1/2 to in order to get 1/8? Well, that's going to be 3. If I have log base 1/2 of 1/4, that's saying what power do I raise 1/2 to in order to get 1/4? Well, that is y equals 2. Log base 1/2 of 1/2 is going to give us 1. And log base 1/2 of 0 is always going to be 1, right? That's one, sorry. That gives us 1. Log base 0 of, log base 1/2 of 1 is going to give us 0 because 1/2 to the 0 is 1. Anything raised to the 0 power except 0 is 1. If I wanted to get log base 1/2 of 2, that's saying, okay, what power do I raise 2 to in order to get 1/2? And I would raise 2 to the -1 power, because 2 to the -1 is 1/2. So y equals -1. The same thing's going to be true for 4. If I take 1/2 to the negative to y, that's going to give me 4. Well, y in this case is going to be -2. Because if I take 1/2 to the -2, that gives me, I want to put that as a fraction squared. So that would be 1/4 under 1, right? Because that's 1/2 squared. 1 divided by 1/4 is the same as 1 times 4 over 1, which is 4. So I would get y is -2. Let's go ahead and plot a few of these points. I have when x is 1/8, so really tiny, y is 3. When x is 1/4, y is 2. When x is 1/2, y is 1. And when x is 1, y is 0. And then I go into the negatives. I have when x is 2, y is -1. When x is 4, y is -2. So here's my function right here. Again, I have a vertical asymptote right here at x equals 0.